Today, we'll show how to test the filter's frequency response with VNA. The VNA is not my personal one. I loaned from one of my friends. It is Copper Mountains Technology product. Here, I show two of the old generation VNAs. This one is the one I still remember I used in the 1980s when I was a student. And this one I used in 1995, at the time when I was still in Philips R&D team for transceiver design. And then after that, I haven't used VNA for 30 years, from 1995 to now 2025. And a few days ago, my friend passed me one of the modern VNA. It looks like this size, very tiny, and I think it's even less than A4 size paper. So the actual size is 29.7 times 16 times 4.4 centimeter, and the weight is only 2.3 kilogram. So to conduct this test, you need to install some of the software. So it's S2 VNA. You can download from Copper Mountains Technology. I will paste the link in the description. And then the calibration kit is ACM2520. The filter, the model is very long here, but I couldn't find the data sheet from the website. So I don't know how to do the calibration for this testing before I know the operation frequency. So what I'm going to do is I'm going to conduct a function test for the filter first. By right, I should conduct the automatic calibration first, but since I couldn't find the specification of the filter, so I will skip the calibration first and then conduct the filter's function test to find out the operation frequency of this filter. So instead of connecting the ACM to the two ports of the VNA, I connected the filter to the two ports of the VNA to conduct the function test of this filter. After install the software, I click S2 VNA here to open the software, and then this software can detect the VNA, which is 0902, because this is connected to the computer through the USB cable. And then you can see here there is a response here. As I just mentioned, we should conduct the calibration first, but I don't know the operation frequency of the filter, so I just do a function test first. Here you can see I only see the S11, which is the almost is the same of the VSWR. So I need to have the S21. So let me see the number trace. I should put 2. Yeah, then I can see the S21 here. And if I want to put them in a separate window, then I put here the allocate trace in 2 windows. Okay, so here is S11, here is S21. And you can see this one, the dynamic range, okay, is 100 dB, but the lowest one is minus 50 dB. So I don't believe this filter only with some 50 dB isolation. And on the other hand, we can't see the noise floor here. This is only a straight line. This is not the noise floor. So to do this, I supposed to change the scale. Okay, the scale is here. So the division is 10. Okay, and then the reference position, I think I should change the reference position. Here is 5, so if I increase it to 6, yes, okay, yes, I can see the noise floor, but you can see the noise floor still below here, and then I don't think I can get enough reference position. So to do this, I should change the scale of this division. I should change, for example, change to 15. Okay, so then I can increase. Yeah, so you see, we can see the noise floor here. But this is not accurate one because we haven't done the calibration yet. But let's see the operation frequency of the filter is around, okay, let's say from 3 gigahertz to 5 gigahertz. That should be enough. So okay, then I would remove the filter and then do the calibration. The start frequency 3 gigahertz and the stop frequency 5 gigahertz. And this ACM 2520 is the auto calibration module from Copper Mountain Technologies. Now I connect the ACM to the VNA and then conduct the calibration from 3 gigahertz to 5 gigahertz. Both ACM and then the VNA are connected to the laptop here through the USB cable here and another USB cable here. So later you can see the laptop can detect both ACM and then the VNA. Okay, let's start the calibration. So this one is, I have the calibration kit is ACM 2520 is the auto calibration module. So what I should do is, okay, let's choose the calibration and then auto calibration, and then because we are testing the filter's frequency response, so we should choose 1 + 2 port auto care. So okay, we are going to measure S11 and S21, so click here and then you see the calibration is in progress, and now it's done. So when it's done, then this is the default frequency. So to calibrate against the filter's frequency, we should change the stop and the start frequency. So let's say the start shouldn't be 100 kilohertz, so we should be put 3 gigahertz. And the stop frequency should be 5 gigahertz, as we just mentioned in the filter's function test. And then the point, I like to change it a bigger one. For example, put 801, 1 point and center, and then 400 at both sides. So we leave the IF band still 10 kilohertz, and then we do the calibration again. So come to here, calibration, auto care, 1 + 2 port auto care. We still do this S11. See, it's in progress, and now the calibration is done. So okay, let's test the filter's real frequency response then after calibration. So this is the connection of the filter and the VNA. I connect the input port of the filter to port 1 of a VNA, and then the filter's output port to port 2 of the VNA. So this is the measured the filter's frequency response. Let's adjust the scale a little bit again. Okay, this one, let's change the division first. Let's put it 15, and then the number of position, let's put it 10, and then similarly here we put the division here 15, and then reference position 10. So you see, this is the frequency response of the of this filter. This one we can adjust a little bit. Division, I think we can back to 10 here, and then the reference we can still put less, let's say 5. Okay, so this VSW, of course, is related to the return loss. So here is the higher the better of the return loss. So let's put some marks here. Let's put mark 1, mark 2, mark 3, mark 4. Let's put the 4 marks. Why I put the 4? Okay, let me see. First one, I want to see the worst case of the this filter. Okay, the worst case for S11 should be here. So let's see how much is the S11. S11 is around minus 14 dB return loss. Okay, that still fulfill the engineering requirement. In telco, normally they put 14 dB for return loss, and then the insertion loss here is around 0.5 dB for this filter. Okay, let's see the 3 dB bandwidth. 3 dB band. Okay, 2 here. Let's say drop around 3 dB. Let's say here should be around minus 3.5. 2, that's too high. Okay, not so easy. Roughly, okay, 3.5. And then let's put Mark 3, another side of 3.5 dB around. Let's drop a little bit. Okay, somewhere here. Drop a little bit. Okay, then Mark 4, let's see the this is put in the center. The center, so you see at the center here, the loss is around minus 0.2 dB, and then the return loss is around minus 22 dB. So roughly you can see the bandwidth of the 3 dB bandwidth of the filter is around 3 to 1.5 gigahertz. Okay, so this is the test process using a VNA to test the frequency response of filter. Thank you, and if you have any comments, please leave in the comments area, and we can see what we can do. Maybe we can prepare another video